Hello and welcome to the DSO Imager channel. This is James, and tonight I'm going to show you the processing workflow that I used on my latest shot of the elephant trunk nebula in broadband. Now, for those that are new to my channel, I just want to make clear that this is not a tutorial. This is just me showing the processing steps in general that I used for this latest shot. I do have some tutorials on my YouTube channel, and honestly, I'm due for maybe updating my complete work-through tutorials, but anyway, this isn't a tutorial, so I don't want any misunderstandings. Now for this shot, I shot it from my backyard. I'm using a SkyWatcher EQ6R for the mount. My backyard is a Bortle 5, and for the telescope, I use an Astrotech AT115 EDT. For the camera, I used a rather old now ASI 1600 mono, and the filters are Chroma LRGB, and the total integration time for this one is 31 hours and 21 minutes. Of that total integration time, 18.5 hours is luminance, and the rest of it is pretty evenly split between the RGB. So let's take a look here. First I'll pull up the luminance, and so this is the stacked luminance, no stretch, no processing at all here. I am using the 0.8 reducer, so the focal length on this telescope with the reducer is around 644 millimeters. When stacking, I did drizzle, and so that should help with the detail. I felt like I had enough data here to do the drizzle, and yeah, I think this looks pretty good for a 4.5-inch refracting telescope. And let's take a look at the colors. So here's our red, here's our green, and here's the blue. Now I do want to point out a quick problem that I had with the green filter. I'll go into more detail about how I corrected this, but if you look closely, you can see a spot there, and that's usually the type of spot that gets eliminated with flats. But you can even see it. It doesn't show up too brightly here, but it's in here on the after the meridian flip. The issue is that I mistakenly cleaned the lens, or the filters I should say, without taking flats to correct this. So most of the data doesn't have this artifact in here. It's pretty faint, but it's very noticeable, and I just cleaned it up using a mask. So I'll go into a little bit of detail on how I fixed that. Okay, so let's take a look at first the color. So combine them. This is what we have here. Some gradients in here that we can see. Let's see, I think the first thing I probably would have done was blur exterminator, but correct only for the colors. So let's take a look at this corner, and yeah, so that's the application of blur exterminator with correct only. So I used the correct only first, and this is based on information that I want to say I read from RC-Astro's website, at least early on when he first put this out. So I don't know if the recommendation changed. But what I do is I do a correct only on the color data, and then I do the background extraction or gradient correction, and then I do color calibration. And after all that's done, then I do come back to blur exterminator, and I'll apply the deconvolution to sharpen the non-stellar and the stars. Okay, so next was the dynamic background extraction. For this, I used SkyWatcher's script automatic DBE. It works pretty well in most cases, and this is what I got after running that script. Now, I did trial by error it a little bit, try different variations of it. I also always test out the gradient correction tool, which also does a pretty good job. It's quicker, but sometimes if you can get dynamic background extraction to work, it does a little bit better of a job, I think. But like I said, I test it out all different ways when I'm processing and go with what works best. Alright, so let's step through this. Okay, it looks like I actually gave it another dose of, yeah, see, I think I followed up with it either another, I may have hit it with that gradient correction anyway, just to kind of balance things out a little bit more. Color calibration, what I'm using is the, I do image analysis to an image solver to solve the image. Notice the pixel size. This is because it is drizzled data. So if your capture software, if you put in all the specifications of your telescope in there, that stuff will be embedded in the image, and it makes things like plate solving easier. So after it's plate solved, it's just a matter of going to color calibration, spectrophotometric color calibration, and you do a region of interest and assign it that for the background. And it'll do a background neutralization based off of that. Alright, so not stretched yet. There's a blur exterminator. So anyway, blur exterminator applied, and then after that we remove the stars. So here's our stars, and this should be, there we go. Okay, and now you can see that problem pretty bad right there. Ugh. And you can see it's the inverse. You notice? It's really weird how that worked. So the splotch was on the green filter, and it's blocking green light, so that's why this is looking purple. And then here, after the meridian flip, it looked like it was giving too much green light. I'm not I can't really explain what happened here. Maybe maybe the subs that were captured after I cleaned the disk or cleaned the filter allowed more green light in here. I don't know. I don't know why it's like that, but it's definitely the inverse, because when I made the mask for this, and I'll show it later, I just flipped it around and then I worked on it there. Alright, actually, let's see, okay, so now we're stretching, and that's what you're seeing here. So here's what it looks like after I stretched it, just the color data, and for stretching I used the generalized hyperbolic stretch tool. And there, look at that. Pretty good, huh? You can still see it a little bit there, but not bad. So what I did, and I wonder if I can demo this. You can see that there's a mask applied here. Let's show that mask. Yeah, so all I did was I made a mask using the game script, right? So that's utilities game. And there, you can even see it here. So I made a circle right around here. And let's see, these, yep. Okay, so you can see three here. So, alright, the game script is here. So this is the mask that I got from the game script. And then I used a range mask to kind of smooth it out, but also control the size with the feathering, with the smoothness slider, and a little bit of trial and error. So like this first one was definitely a little bit too small, and when I was applying the adjustments, I had this like faint ring on there. So anyway, let's take this mask and I can demo what I did here. So mask invert, and let's get a little preview box. Wondering if I should do a separate video just showing this, because I'm sure a lot of people who might be interested in seeing this but may not be interested in watching a workflow video will miss this. But anyway, so it's too much purple, right? And it's purple. My thinking is that it's purple because the green light was being blocked by this blemish or whatever. And so to make this go away, I actually need to increase green a little bit. All right, look at that. Like, boom. You can almost not even see it. There may be a faint little bit. So what I could do is I could do this and hit apply. All right, let's clear the mask so we can see it. Hit apply. And there. I mean, that's it. That's basically done. What happens if I give it another shot of green? Yeah, see? Now it's too much. So maybe a little bit more tweaking here. Maybe just a touch more green. Or maybe I could just use the K channel. See? So just a little bit. I could even maybe pull back on saturation to help with some of the other colors that are in there. I don't want to go too far. But anyway, so I think this gives you a good idea of what I did to take care of that halo. So I was contemplating just tossing all the subs that had this in here. But after seeing that I can make a pretty clean mask, and I decided to just run with it. Oh, see, that's definitely too much. So anyway, to address the issue here on the meridian on the flip side, since it's coming from the same spot, right? I just had to flip this with geometry, fast rotate 180 degrees. Yeah, that's fine. And now, right, there it is. So mask, invert, same kind of deal. Only difference is now there's too much green in here. So what are we going to do? We're just going to pull back on green. Look at that. I mean, that's pretty good, I think. Let's see. You got to always zoom out because I've had times where it's like, oh yeah, that worked really well, and then I zoom out and it's like, nope, I can still see it. Yeah, see, that's actually a little bit too dark now, I think. But we can just boost that up here. Oops, I don't have the preview on. Yeah. My computer's a little slow right now. That looks pretty good, I think. Yeah. So, I mean, you can tweak it a little bit more, but this is a way that you can maybe salvage some data. Ideally, you would have flats that would take care of that, but if you do something that interferes with your image train, like take the camera and filter wheel off and clean your filters, you really have no hope of getting a flat after doing that is going to solve that type of issue. And then your only chance is to address it in software. And if it's something like a pretty even circle, it's pretty easy to fix. Alright, so anyway, don't be surprised if I just grab that segment and make it a standalone video. Let's move on. Okay, oops. Alright, where are we? I think we're here. Yep, in fact, yep, there you can see I was working on that. So that's what it looked like after I corrected it. And doing a little bit more tweak in there. And I think I got to this point. At some stage I went into Photoshop. It might be... No, I didn't go to Photoshop until after I combined the Luminance. Alright, so I got to this stage, and then I decided to work on the Luminance. So Luminance, first thing I did was dynamic background extraction. Let's get these guys out of the way. Let's see, and then I'm setting this up so I can test different settings with Blur Exterminator. There's our Blur Exterminator. I mean, look how good. That's not, I don't think that's too bad for a 4.5-inch refractor. A value refractor at that. Let's see. There we go without the stars. I mean, this right here is worthy of being a picture, I think. It's so clean. All right, there's a stretch. So this is what it looked like after the stretch. I think you can see it, yeah, brighten up a little bit. So what I do when I'm, before I combine the luminance and the RGB, I usually pull up statistics. Where is it? Right here. And let's see. Yeah, and I look at these numbers here and try to get them pretty close between the RGB and the luminance. That way the luminance doesn't overpower the broadband data. And so I think this is where it ended up with. Usually when I see this, I had a hard drive fell on me once and it started doing this stuff and it caused all kinds of problems. Anyway, let's proceed. So I took this into Photoshop, and what I do in Photoshop is I use the camera raw. I do two things in Photoshop mostly. Is I use the camera raw filter to kind of work the contrast. I like using the dehaze tool, the clarity tool, and then of course the shadows and lights and whatnot. And I may tweak the colors in Photoshop. The other thing that I do is I clean up all these artifacts left over from the star removal. And the way I clean these up is I just use the content fill function on Photoshop. I know now, so the typical thing in PixInsight would be the clone stamp, but clone stamp doesn't work very well when you have a lot of nebulosity around or a lot of changes in colors. I have not tried it out yet, but call out RC-Astro again. He's got a script where it takes reference material from all around. So it's like clone stamp, but with more reference material, and that probably works fine. But using the content aware fill in Photoshop works really well too. Alright, so here we are in Photoshop. I thought I'd just kind of show you really quick the things that I'm doing. And I gotta say, I'm not a Photoshop expert. I'm way more comfortable in PixInsight than I am in Photoshop. So I'm sure there's better ways to do this sort of thing. But anyway, just to kind of give an idea. So that's what dehaze does. The one thing about it is it's very easy to overcook an image. I see a lot of images, especially like on places like Astrobin or on Facebook in particular, where you see a lot of overcooked images. I think it's easy to get some tunnel vision when playing with these sliders, and you end up with, in my opinion, something that's not quite like very high contrast. You know, I guess sometimes the contrast is to hide blemishes or whatever, but like this doesn't look natural to me. It looks overcooked. Alright, but that's the main thing that I mess around with. I'll do some stuff in here, depending on how, like, if these areas are too dark, I could raise this. Yeah, I'm just kind of demoing what the sliders are doing. I wanted to show the content aware functionality. Let's see, I think. Yeah, like see, so this is an artifact left over from star removal. So you can just kind of draw a circle around it, fill content aware, and there. And so, you know, it's doing stuff in here. This is definitely I would call it generative AI type stuff. So it's definitely doing something in here. It's guesstimating what's behind here. So it's definitely something you want to be careful you don't overdo it. And in some areas it doesn't work great. Like this is a hard spot because there's actual nebulosity in here, and we don't really want to change the structure. But that blemish has just completely destroyed whatever is behind there anyway. So it's not like you're changing the data. Oops, you're just you're just overriding these blemishes. So some people may find this as cheating or whatever. And I definitely agree, it's a fine line. I think if you disclose that you're doing stuff like this, it's okay. And by showing how I'm doing it, I feel like I'm disclosing it. So the thing is, in the past I would leave these blemishes here. The problem though is that when you add the stars back in, they look like funky halos, and it gives your whole image kind of a I don't know, washed out look to it with the stars in there. So I think doing this really helps the overall image. And like I said, I'm being very selective about where I'm applying it. Like, so these little spots here, I'm not going to mess with it. This spot might be worthy. Keep in mind, this is at ASI 1600. The sensor cover does not have any kind of anti-reflective coating on it, and it has a reputation for making some really nasty halos on really bright stars. So like all this stuff I wouldn't touch. It's just the ones where it's obvious that it looked like a star was there that was deleted. Oops. So anyway. Alright, so that's what I'm doing in Photoshop. So I believe this is what I ended up with. So we got a mask on there. Oh yeah, just a red mask. This is what I ended up after working in Photoshop, and then it was a bunch of little tweaking and curves. If you've watched some of my older videos, before I used to go into Photoshop, I used to just spend a lot of time tweaking the image with curves. So by going into Photoshop and working the camera raw filter, it's kind of saved time because I can pretty much get the same effects just using curves in PixInsight, but it would take a lot longer and it would have a lot more trial and error. So yeah, you're seeing just very minute changes. The image really doesn't change much from this point forward. Uh, I got a little hung up on the color of the red and how I wanted to make this look. I wanted this little bit to stand out a little bit from the background, and I definitely moved into that realm of tweaking forever phase. Here's my first attempt at putting the stars back in. I just used pixel math to put them back in. And in this shot, I made the stars really, really tiny. And you know what? I wasn't too pleased with it. You can see other various attempts. I went back to the starless image and played more with the color and the saturation and came up with some more variations. I got to one of these stages. I don't remember exactly which one now, but I got to a point, I think it was probably this one or this one, where I put it on that 24-hour cooldown period. So for those that are unaware, what I do when I finish processing an image is I'll wait 24 hours before I publish the picture so I can come back to it. And I always find things that I want to change afterwards. And this prevents me from sharing out a picture and then I realize, oh no, I wanted to do something different or I don't like the way it looks. And I make a change and I make an even better version, but I've already shared the previous version and I have this issue about spam. I don't like to receive it and I don't like to send it. So if I share a picture out on social media, that's it. That shot's been fired. I'm not sending variations of it out there. I'll upload different variations to AstroBin sometimes with notifications turned off because again I don't want to spam anyone. But anyway, that's why I give it a 24-hour period. So I came back and I did a little bit more, and here are two different versions, and what you're seeing here is on the left is with those tiny stars, and I just wasn't too happy with how this was looking. And then here's with larger stars. So larger stars and more stars. And I think the stars look a lot better in this version. And then I cropped it. I was relying on the auto crop in PixInsight, but you can see how it's like, I don't know if I would call it stacking artifacts. This chip, this sensor tends to drop off near the edges anyway. So I just gave it a little trim. And this is the final image. Alright, so it was a fun image to work on. I enjoyed collecting data on this one. Lately, I've been getting the bug to shoot broadband on classic narrowband targets, and that's what this is. And with my Bortle 5 skies, shooting the really dark nebula and stuff like that I'd like to shoot is a challenge. And so I think, at least for now, I'm going to just capture brighter broadband targets while I do this broadband thing. Of course, I'm not giving up on narrowband. I do run three astrophotography rigs on each clear night. So my 8-inch edge is currently on narrowband duty, and I've got like, I don't know, 30 plus hours on the Wizard Nebula, which is one that I've never pointed the 8-inch scope at. So stay tuned for that one. Alright, so if you've made it this far, I'd like to thank you. Thanks for watching. Don't forget to give it a like, subscribe to the channel if you haven't already. Note, I do have some affiliate links in the video description, so if you are inclined to get something, especially if it's something based on one of my videos and you click one of those links, I'll get a little bit of a commission. Other than that, clear skies and good evening.